It's time. The potential of data and AI is too big, and the problems we're solving are too important for it to be so hard. It's time to set your data up for success. Time to let it drive, because data is all grown up now, but we still haven't taken the training wheels off. It's time to be open, to unlock, unlimit, and unleash data. It's time to work together as data teams, as a data community. Innovation doesn't happen in isolation, because when we're united, we do what teams do best. Above all else, it's time to simplify. One place for all your data. One foundation for every workload, from BI to AI. One platform that runs where you run. One architecture that puts an end to the trade-offs and brings it all together. One lakehouse. Databricks helps data teams innovate faster on the world's first and only lakehouse in the cloud. Open, simple, collaborative. Now you can have it all your data, all your analytics and AI, all your data teams. One platform for today and in the future. It's time for Databricks.
Hello, everyone, and welcome to our virtual event, The Best Data Engineering Platform is a Lakehouse. My name is Ori Zohar. I'm a product marketing manager at Databricks and glad to be here hosting this event. We have some terrific speakers coming up that will provide us with overviews, demos, success stories, and best practices around data engineering and streaming capabilities of the Databricks Lakehouse. We'll kick things off with Michael Armbrust, Distinguished Engineer at Databricks, who will walk us through the Databricks Lakehouse platform and how it is the best platform for doing data engineering. We will then hear from Karthik Ramasamy, Head of Streaming at Databricks, about data streaming on the Lakehouse. Then we'll have Jan van der Vet, Staff Product Manager, show us how exactly it all looks and feels when things come together in a demo. Followed by a talk by Chris Inkpen, Tech Evangelist at Honeywell, who will walk us through a real-world story of how Honeywell is using the Lakehouse platform for streaming and data engineering. After that, we'll dive a little deeper into Delta Live Tables and Databricks workflows with two best practice sessions provided by two staff product managers at Databricks, Ray Zhu and Roland Faustlin. Finally, Angela Chu, a senior solutions architect at Databricks, will share some of her experiences working with customers on common data engineering challenges and solutions. So some great sessions here. At the end of the event, we'll have a live Q&A session with a panel to answer some of your questions. Before we get started, though, here's a few housekeeping items. The webinar is being recorded, so it will be shared afterward and available on demand. You can use the Q&A box at the bottom to ask your questions. We have subject matter experts ready to help answer them throughout the event. At the end of the event, we'll take some questions as well, as I said, with a panel that will answer them live. If you are attending this event live or on demand, you have the opportunity to take advantage of a $150 certification voucher. More info on that at the end of the event. We can now kick it off with our first talk of the day by Michael Armbrust. Michael is a distinguished engineer at Databricks, and he is the creator of Delta Lake and Delta Live Tables. Michael will walk us through the Lakehouse platform and how it is the best platform for data engineering. Take it away, Michael.
Thanks, Ori. I'm really excited to be here today to talk about the Databricks Lakehouse platform. Before we get started on that, why should we even care about the Lakehouse? We've been seeing this trend for many years where these big tech companies have been causing all kinds of disruptive innovation through their use of data analytics and AI. Basically, their main competitive advantage is their ability to acquire huge amounts of data, store it, and process it so they can understand how their business is working and also predict the future. But I don't think this is actually unique to these large tech companies. And in fact, I would say in 5 years, every company is going to be defined by data, analytics, and AI. And you might ask, how is that possible? Well, let's take some examples of the data-defined enterprise and see how analytics and AI are essential to their business. One area is customer engagement. You can bring relevance and hyper-personalization to every touch point. You can predict which customers are going to churn and take action before that happens. You can also use data and AI in product development. You can understand how people are using your product and use it to decide how you're going to change that in the future. You can use it to optimize your workforce and unlock productivity through real-time insights. So people are no longer waiting for data. They just have it at their fingertips as soon as they need it. And finally, you can use it to optimize the efficiency of how your business operates and maximize productivity. When we see customers start on their data journey, they often go through this maturity curve. And we see this kind of broken into kind of two key sections. In the beginning, you're mostly looking at the past. You're trying to understand what happened. You start by just trying to take all of that data you've collected and clean it so that it's ready for consumption. Once you've got clean data, you can start building reports that analyze how things have been happening in the past. As people get more advanced, they'll start asking questions and using the data to answer ad hoc queries, and they'll start exploring it to discover new insights. Once you've got all of that mastered, though, you can start looking forward into the future. You can start asking questions like what will happen and how is the best way to respond to that. And when you get really advanced, you can finally start automating it so that those decisions are automatically made by the system with no human intervention. And so kind of in summary, what we see is there's kind of two classes here. You have business intelligence where you're looking at the past, and artificial intelligence where you're starting to model and predict the future. Now, this sounds great, but the problem here is most organizations struggle because their systems aren't able to support their goals. And the reason for this comes down to this dichotomy between the traditional data warehouse and the data lake. We have the familiar data warehouse, our traditional relational database, which is highly reliable and very efficient, and it's been used for many years to do business intelligence and SQL analytics. But then came along the data lake, and this unlocked a whole new type of data. We could now store vast amounts of raw data in the form of logs, text, audio, video, or images. And the problem is, having these two different worlds, you end up spending a lot of time copying data in between them. And this disjointed and duplicative data silos lead to problems. Additionally, these two different worlds have incompatible security and governance models. So you're spending all of your time trying to reconcile who has access to what data and who shouldn't have access to what data. And the reason you end up kind of bridging the gap between these two worlds is neither world supports all the different use cases you want. The data warehouse was great for doing business intelligence and SQL analytics, but only the data lake could do data science, ML, and low latency cases like data streaming. But we think that there's no reason to have these two disparate platforms. Instead, we propose the lakehouse paradigm. The idea here is you have a single reliable data platform that can efficiently handle all data types, whether it's structured data or unstructured files. And the foundation for this is Delta Lake, which I'll talk about in a little bit. On top of that, you have one security and governance approach for all of your data assets that works on any cloud. And we call this Unity Catalog. And then finally, you can do all of your ML, SQL, BI, and streaming use cases on top of this platform. These are all of your different data applications. So now we have the data lakehouse, one place for all of your data analytics and AI unified into a single platform. And this is something that not just Databricks has noticed. In fact, we've seen it across all of the different cloud vendors. You can see that Azure has been talking quite a bit about the lakehouse. Google has also been talking about their open data lake. AWS has been, one of the places where the lakehouse was born. And even traditional data warehouses like Snowflake are taking note. But one of the things you'll notice is, do these offerings really stack up, and are they a true lakehouse? And one of the key problems here is, while it's great to have open support for open formats, you really have to architect your system from the beginning in order for it to be cost effective to operate in this way. Here you see a comparison of the total cost to run a standard decision support benchmark called TPCDS on 3 terabytes of data. And so what we did was we basically took this benchmark and we tried to see how all of these different cloud data warehouses would perform when they were using open lakehouse formats. And what you can see is Databricks SQL is dramatically cheaper. While these other engines are able to operate on lakehouse formats, they aren't optimized for it. And so you end up paying for significant inefficiencies. And we wanted to drive a little bit deeper and understand exactly where was that cost coming from. And you can see it's not just running the queries. In fact, a significant part of the expense is just loading the data into the system and allowing it to do auto clustering so that you can get good performance. In Databricks, since we've kind of optimized for the lakehouse architecture from the beginning, you can see all of the steps of the data journey are dramatically more efficient and therefore dramatically cheaper for you. And it's not just benchmarks that are showing this. We've seen performance and efficiency from many of our different customers. For example, Johnson & Johnson used the lakehouse architecture to replace 35 different data sources, streamline their supply chain management, and dramatically improve their inventory predictability. And what this meant was they were able to get the data significantly faster, and they were able to cut their cost for data engineering by up to 50%. So what does it actually take to build the lakehouse? Now I want to take some time to go through some of the different layers and talk about why they're important. So at the bottom of the stack, we have Delta Lake. Delta Lake is the system that allowed us to, rather than store a bunch of Parquet files out on cloud storage, it actually took all of the nice things of cloud storage, meaning that it's very cheap to operate and incredibly elastic, so it can scale to any amount of data that you want to store in it. And it changed it from just being a dumb collection of files to a full relational table with all of the benefits that means. So what Delta Lake brings is both data reliability and performance to your data lake. So it's designed from the beginning for high performance transactions at massive scale. It can handle, millions of partitions and millions of files. And it brings reliable table operations by bringing ACID transactions to these operations. So you no longer need to worry what happens when there's a failure. ACID will automatically take care of it for you and clean up. It was built for the beginning from streaming because we knew that low latency was becoming increasingly important. It's also the only industry standard, completely open way to do data sharing. And a key benefit here is it's completely open and community driven. So it's not owned by one single vendor, and it has inputs from many different people around the space. The community is pretty big, and this is one of the, I think it's key enabling parts of Delta. All of the source code is available on GitHub. Governance is managed as part of a Linux Foundation project. We talk about the public roadmap, is all available out there on the internet. And finally, we have community events and office hours where you can meet other people who are trying to solve similar problems. And what this means for you is you never need to worry about being locked in by your data format. Another key benefit of being an open ecosystem is it means that you aren't stuck using one tool for one job. You can use whatever the best tool that you prefer is at any time. So Delta Lake has always had support for Spark and Hive and some of these other kind of, more traditional big data formats. But as we've expanded the project, we added support for Beam and Power BI and Kafka. And we just recently added support for Flink, Trino, and Presto. And in the near future, the ecosystem will continue to expand as we add support for Pulsar and Google's BigQuery. And one of the key parts about Delta Lake is performance. It brings a significant performance improvement, not only over just storing a bunch of Parquet files, but over many other storage formats that have recently been created. We again ran this TPCDS benchmark on Delta Lake and two of its other open source competitors. And what we see is Delta Lake is dramatically faster. In some cases, it's almost 2 times faster. And in other cases, it's almost 4 times faster than these other formats. And what that means is you can save a lot of money just by using Delta Lake. And on top of, now that we've kind of figured out exactly how all the data is going to be stored, now we can talk about how we're going to govern all of that data. And our answer for that is Unity Catalog. Now, before we talk about how Unity Catalog solves these problems, talk about what these problems are. So when you just had a data lake, you were basically just managing permissions on top of a big collection of files. And this is actually pretty difficult because it's incredibly coarse-grained. It means that you can't, shield individual rows or individual columns, and that kind of coarse granularity makes it very difficult. You end up creating lots of copies in order to deal with it. Another problem is the metadata about the files and the metadata about the tables was often stored in 2 different systems, and they can be out of sync, and it was just a lot of orchestration and management. And finally, if you have a separate data warehouse, you now have a different governance model. You need to think both about these files as well as the management of your data warehouse. And if you're getting more advanced and you start doing ML models and dashboards, you have yet another governance model to worry about. And this is why we created Unity Catalog. It's a single permission model for all assets, whether it's collections of files or Delta tables or ML dashboards and models. You can manage all of these things in a fine-grained way using standard ANSI SQL grant and revoke semantics. And this means you not only have this kind of centralized governance, but you also have centralized auditing and lineage as well, so you can understand exactly where data is coming from and how it's being used. And so to summarize, the data lakehouse brings all of your different data into one place, into one platform, so that you can do all of the different operations on top of it that you want. But now I'd like to focus in on one of those challenges, which is data engineering. And the reason I think this is so interesting is because many organizations struggle. They can start, getting data in and analyzing it, but as the scale increases, maintaining that infrastructure at scale becomes very complex. And what we've seen is, as a result of this complexity, a lot of data that is collected is actually just never used. It's just thrown out. And the reason for this is it's a very hard problem to do this data engineering. Data engineers spend a lot of their time on undifferentiated heavy lifting. Well, that means that they spend a lot of time hand coding data ingestion and transformations. They manage a whole bunch of scalable infrastructure. They have to think about orchestration and managing their production workloads. And again, as you have all of these different tools, you end up having incompatible governance models that need to be managed. And this is why we think the best data engineering platform is a lakehouse. Let me walk you through that. So the idea here is we're going to be able to connect to all of those different open sources that the lakehouse enables. We'll be able to adjust, transform, and organize. And then that will allow us to do streaming analytics, BI reporting, and data science and ML. And we have two kind of key tools for doing this: Delta Live Tables, which is the best way to do ETL. That means whether you're ingesting data using our tools like autoloader and copy into, or transforming it until it's ready for consumption, doing automated ETL with DLT in either batch or streaming. And then since once you've got all of the data in, now you need to do all of those operations on it, and that requires orchestration. And this is where Databricks Workflows comes in. This gives you reliable orchestration for data analytics and AI that works across the entire platform. Let me dive into both of these tools. First, let's talk about ETL. Why are we doing ETL? Well, it's basically a fact of life that all data starts off messy. And so you need to take this messy data, you need to filter it, clean it, augment it, and then you need to build business level aggregates that actually answer questions. And that enables all of this downstream stuff. But this picture here that I'm showing is really quite simple compared to what it looks like in real life. A real data architecture often has tens to hundreds of tables with complex interdependencies between them. And what you often find is you end up spending a lot of your time on managing this brittle infrastructure. You have a problem for ETL, so you bring in Amazon Glue in order to do that. But then you need to understand exactly how many rows are being processed to make sure nothing's getting dropped, so you bring in Datadog. You want to make sure you're getting the best out of your machine, so you bring in some low-level metrics from Amazon CloudWatch. You need to orchestrate all of these dependencies, so you have to set up your own Airflow cluster. And then after that, you need to ingest some data from another data source, and so you end up bringing in Azure Data Factory. And then I need to run some reports and SQL queries, and so I use Oozie because this old legacy team is doing it. And then finally, we can pull in another tool like Azure Synapse. What you see is this tooling ends up dominating all of your time. And this is why we created Delta Live Tables. Delta Live Tables makes it dead simple to build reliable data pipelines. And in fact, these few lines of SQL are actually a full end-to-end production pipeline. Let me walk through it really quickly. First, we see this create streaming table where we're actually doing ingestion of raw data. But the simplicity of this SQL is actually kind of hiding a lot of what's actually happening under the covers. So under the covers, we're taking this directory of JSON data called raw data. We're automatically inferring the schema to understand what that data looks like. Cloud Files also allows you to automatically tune how you're going to handle evolution. If new columns appear or columns disappear, or they change data types, all configurable by Cloud Files. The other really nice thing that it's handling is it's handling ingesting this data exactly once at any scale. So we'll integrate directly with these underlying cloud storage systems to make sure that we're getting actual push notifications. So even if there's tens of files or tens of millions of files, it's going to work the same way. Once the data is ingested, now we can use materialized views to transform and clean it up. And the nice thing here is you can see we say select from live.raw data. That's automatically creating a dependency between these two tables, and the system will automatically orchestrate how data flows between them. What this allows you to do is dramatically accelerate your ETL development. You can write code in SQL or Python, and DLT automatically handles the orchestration of the DAG and all of these complex cloud problems like handling retries and changing schemas. We automatically take care of the infrastructure for you. You don't really need to worry about exactly what type of cluster and exactly what type of instance. We have automatic recovery, we have automatic auto scaling, and we automatically optimize the performance of how this pipeline is going to operate. We have built-in tools for ensuring high data quality. So we can automatically basically allow you to specify these declarative expectations about what good quality data means for you, and the system will automatically monitor and enforce these rules. And then finally, as you can see in this example, we unify batch and streaming into one simple language. So you can have the simplicity of SQL while having the freshness of streaming all in one single API. And a key part of the DLT story is end-to-end observability and monitoring. So every part of how your pipelines operates is actually captured in the system called the event log. And what that means is you can now create dashboards that tell you not only how much data is being processed, but also kind of low-level details, like exactly what the quality is and if there have been any data quality problems over time, so that you can find them and proactively fix them. And now that we've got all of the data in, now it's time to orchestrate all of that analytics and AI that you can do on top of it. And the story for that is Databricks Workflows. Databricks Workflows allows you to orchestrate anything, anywhere. You can use it to run old school Spark jobs wrapped up as jars, Databricks notebooks, orchestrate Delta Live tables, to train models, to run Python scripts, or even use outside tools like dbt. The nice thing about Databricks Workflows is it has a simple workflow authoring experience. All you need is a web browser, and you can log into our UI to create these DAGs and ML workflows. It's deeply integrated into our platform, so you have centralized monitoring and centralized observability. And it's fully managed. It's incredibly important that your production workloads always run on time, no matter what's going on in the cloud. And Databricks Workflows takes care of that. And we have proven reliability from 10 years of running these critical workloads for our customers. Let's walk through what an example workflow can look like. So you often start by ingesting data and transforming it using autoloader and DLT. Then you can do some more filtering and quality assurance, again, using DLT, SQL, or Python. Then you can integrate with tools like MLflow, where you can actually do things like feature extraction. And finally, we can save those features and train a machine learning model that will allow us to predict what's going to happen in the future. And one of the cool things about the data lakehouse is it's not just about Databricks. There's an entire ecosystem of partners for doing everything from ingestion to data pipelines to governance, and then all of the tools on top for doing BI, dashboarding, machine learning, and data science. And we've had over 7,000 customers see success with this over the years. I want to dive in on just one of those customers, where we're talking about streaming an ETL with Shell. The problem here is basically predictive maintenance and analytics. So they have all of these big turbines around the world, and they're producing tons and tons of sensor data on how every individual component within that large complex system are operating. And one of their key problems here is they want to understand and predict when things are going to break, so they make sure they have the right parts and the right personnel and minimize the downtime caused by that outage. And using DLT, they were basically able to collect all of this data, multi-trillions of records, and continually improve their ability to do that analytics. And what that means is now they have hundreds of engineers collaborating on these different use cases, saving them millions of dollars in repair costs. And we have similar stories with Databricks Workflows. In this case, we're talking about YIPIT data, where they collect different data from hundreds of websites around the world. In the past, they had a lot of problem with siloed teams that were unable to kind of scale their legacy data technology. They were spending all of this time managing their own Airflow cluster rather than actually spending the time getting insights from their data. And so when they migrated from Airflow to Databricks Workflows, they had a single unified platform that allowed them to manage the entire life cycle of doing data analytics. And the end result here was they lowered their costs by up to 60%, and they also reduced the processing time by 90%. So that means they're getting faster answers, significantly cheaper. And so to summarize, we believe the best data engineering platform is a lakehouse. It gives you reliable data for analytics and AI by giving you simple batch and streaming data ingestion with Delta Live tables, reliable orchestration for all the things you do with Databricks Workflows, and it's built on top of a foundation of reliability, performance, and governance that you get from Delta Lake, Photon, and Unity Catalog. Thank you.
Thank you, Michael, for that great introduction to the Databricks Lakehouse and data engineering on the Lakehouse. We'll now go to Karthik Ramasamy, Head of Streaming at Databricks, who will tell us about data streaming on the Lakehouse. Take it away, Karthik.
Okay, so I'll be talking about data streaming on the Lakehouse. So similar to the data engineering section, I'll talk about the importance of data streaming practice today. And what about the barriers of adopting streaming in organization, and why we believe Databricks a lakehouse platform is the best, provides the best experience for data streaming workloads. As with data engineering, we do believe data streaming is best on the lakehouse for all the same platform benefits, such as the ability to process structured data and unstructured data, and running streaming pipelines along with the batch pipelines, and in addition to the benefits that are provided by uniform governance model, as well as unified data management with reliability and performance. The world operates in real time because of the fact that the world is entirely connected, and we experience the real-time decisions that we make every day in both in our personal lives and in professional lives. So which means the organization have to make the decisions in real time as well, so that they can either stay ahead of the competition or stay in race altogether. I mean, IDC in 22 quotes that business always happened in real time because people buy things in real time, packing happens in real time, goods are shipped in real time, and bad players try to access your data in real time. So which emphasizes the importance of real time. And Gartner also 2021 indicates that the decisions will be made in real time, regardless of whether real-time analytics are available, because the world is more event-driven and the organization has to respond immediately as events unfold. So the importance of real-time cannot be overemphasized. So in the world, the real-time data is awash everywhere. Every organization generates vast amounts of real-time data, either from individual or across teams, or even from external organization. For example, transactional records or business data is generated from operational data systems, and customer and partner interactions are captured in the form of web clicks, social posts, emails, and instant messages. And third-party interactions also creates a news feed, weather data, market data, and real-time traffic data. And finally, IoT sensors provide a lot of IoT events from machines and sensors as well. And real-time data is everywhere. So now this real-time data creates new opportunities for all kind of real-time applications encompassing real-time analytics, real-time operational decision-making, and real-time machine learning. That includes fraud detection, personalized offers to lure the customer into buying additional items during a session, and making a smart pricing decisions based on the current amount of demand versus traffic, and also like enabling predictive maintenance to proactively figure out whether a machine is going to fail or not. But still, IDC has indicated that less than 25% of the organizations are doing streaming altogether. And but why is that? So let's look at a few reasons of why the adoption is so low. So data streaming is hard for most organizations, and there are three reasons for it mainly. First of all, it requires the existing teams to learn new APIs and languages and learn new systems altogether. So that makes it very difficult to existing data analysts, data engineers, and data operational teams to learn all these new languages and tools, which makes it a big barrier to entry to streaming. Second one is it requires complex operational tooling and stitch together a bunch of services to do monitoring and infrastructure scaling. Hence, it makes it very difficult to deploy and maintain streaming data pipelines that runs reliably and efficiently in your production environments. Finally, real-time data and historical data are usually in different systems, making it harder to share the data across teams and across even external organizations, and also providing appropriate governance model as well as security models. So Databricks made Databricks much more simpler for organizations, so that they can enable real-time applications, machine learning, and real-time analytics on one single platform. There are three aspects on the Databricks Lakehouse platform that makes data streaming very simple. First of all, you can enable all your data teams, which means that includes data engineers, data scientists, analysts, can easily build those applications with the languages and the tools that they know already. Second aspect is simplify the development and operations by reducing complexity of operations by automating many of the production workloads, such as the recovery to restart failures and infrastructure scaling and monitoring and building and maintaining these real-time data workflows using the SQL editors and notebooks that you're familiar with in Databricks environment. Finally, it's one platform for both streaming and batching data, thereby eliminating the need for data silos and provide a centralized security and governance model and providing complete support for all your real-time use cases. So at the core of Databricks Lakehouse platform is the Apache Spark structured streaming that enables real-time streaming pipelines. And with Databricks Lakehouse platform, Apache Spark structured streaming is provided as a managed service that provides incredible threshold of 99.95% uptime. Apache Spark structured streaming is a very popular open source project that has been adopted by thousands and thousands of organizations. And when we interviewed with some of these customers, and they indicated why they adopted Spark structured streaming, and here are the top 5 reasons. First is unified batch and streaming APIs. So that allows the developers to use the same business logic across batch and stream processing without having to learn new languages and API altogether. So that makes it seamless. So the seamless aspects comes by the enabling some configurations called trigger now versus trigger periodically versus trigger availability. So then the next one is fault tolerance and recovery. So Spark belongs to a class of pessimistic streaming systems that allows checkpointing at every step of the processing, thereby enabling quick recovery when in the case of machine failures or process failure or instance failures. So by providing automatic checkpointing and failure recovery, thereby allowing reliable operations. In fact, for Spark structured streaming is only one of the, or probably the only streaming engine that can run in Spot instances of Amazon Cloud or even Azure Databricks Cloud that reduces that total ownership cost. So Spark structured streaming also provides high performance and throughput. One of our Databricks customer runs more than 14 million events per second, which amounts to 1.2 trillion events per day for the most challenging streaming workloads. And in open source, there are some data where there are organizations which are running even higher than these throughput workloads as well. And the fourth point is reason why Spark structured streaming is popular is flexible operations, which allows you to express arbitrary logic and operations on output of a streaming query to incorporate multiple things or do more of absurds using an operation call for each batch. And the final reason is Spark structured streaming provides native stateful processing that allows you to support for stateful aggregations and joins along with the watermarks for bounded states. So in Databricks, streaming is delivered using my integration of multiple different products to provide with a tight integration so that the users can get a seamless experience. Now let's look at what are they. So by using autoloader and message bus connectors, we can seamlessly bring data from a disparate set of or myriad set of systems into Lakehouse. And Delta Lake is the open source and the data is ingested into the Delta Lake, and Delta Lake is a open source format for reliable, secure, and performance storage. So then we provide the Unity catalog for data governance and sharing across the data present in the Delta Lake. Then the third one is Photon for Lightning data processing with using vectorized engine for both batch and streaming workloads. Then Delta Live Tables provides declarative approach to expressing batch and streaming workloads, and with operations taken care of by the workloads for end-to-end orchestrations. Coupled with Databricks SQL, you can instantly dashboard the data that is generated from the streaming engine, so that you can make instantations or power some real-time dashboards right away. Then the third one is like real-time machine learning is enabled by data coming from streaming to look at new features that's coming in real time and upgrade our models or enhance your models so that the scoring and prediction is much more accurate to the moment. And finally, at the core is the Spark structured streaming, which is adopted, which is a popular open source project that is adopted by thousands and thousands of organizations. And it provides a single API that allows you to express batch workloads and streaming workloads. So now let us look at how building streaming pipelines and applications are faster. So you can, with the Databricks Lakehouse platform, you can develop pipelines, streaming pipelines in a similar SQL and Python languages that the teams are already familiar with. And using simple semantic extensions like in SQL, you can convert your batch workloads into streaming workloads. For example, in the example shown with the word streaming added in the create table, you can load data from cloud files, which is actually the S3 storage, and look at all that data coming from that select this thing and ingest into a streaming table called raw data. So that way, like we can change the batch workloads to streaming workload with minimal changes. And with the unified APIs for streaming and batch, there's not much change you have to make to use the existing tools and code and the existing tools to get to streaming from batch quicker, so that adoption is much faster. So the data streaming for the data lakehouse platform, data streaming has become much more simpler, and you can enable data processing from batch to streaming right away. And you can unlock real-time analytics, real-time machine learning, and real-time applications, thereby enabling faster decision-making, more accurate predictions, and improved customer experience. Some of the customers that are doing streaming in Databricks includes Walgreens, AT&T, and Edmunds. Walgreens powers the real-time analytics using Databricks Lakehouse platform, and the use case encompasses real-time reporting on customer data, thereby enabling pharmacists to provide more personalized recommendation and advice to patients. AT&T uses real-time ML to detect fraudulent activity to prevent illegal unlocks, robocalls, robotext, and identity theft. And similarly, Edmunds uses streaming for real-time application for automated real-time pricing based on inventory and market factors that drive more than 200% higher conversion rate marketing offers.
In fact, we have more streaming customers in every industry, ranging from established Fortune 500 companies to startups. And our streaming business has been growing. The proxy number that we have given is that the number of streaming jobs have grown from somewhere up to just crossed 7 million as of January 2023. So this is actually like we are witnessing more than 150% year after year streaming job growth. And this shows the popularity of the streaming platform on the lakehouse.
So the top 3 reasons why Databricks customers love streaming on the lakehouse: ability to build the streaming pipelines and application faster using existing tools and existing team with a minimal learning curve, and simplified operations from automated tooling to reduce the complexity of operations, and unified governance for real-time historical data by bringing all the tools and everything as a tighter integration into a single lakehouse platform for sharing as well as providing security.
Thank you, Karthik. Now we'll go to Jan van der Vet, a staff product manager at Databricks, who will give us a demo to show all these lakehouse capabilities that we just heard about. In this demo, we'll see how workflows is used together with Delta Live tables, as well as some other lakehouse capabilities to implement a common scenario for streaming and data engineering. Over to you, Jan.
Hi, my name is Jan van der Vet. I'm a product manager at Databricks working on workflows, and I'm very excited to showcase Databricks workflows to you today. So Databricks Workflows is an orchestrator native to Databricks. It's all about reliable orchestration for data, analytics, and AI. You can orchestrate anything, anywhere with workflows. We provide a very simple authoring experience, a deep integration with everything in the lakehouse, which I will showcase in a minute. It's highly reliable, and it's fully managed, so you don't have to worry about anything related to managing servers or keeping track of things. Everything is done by Databricks. So to showcase some of the functionalities of Databricks Workflows to you today, we'll go over a use case. So here, this is the Workflows UI, and this is the job that we'll be looking at today. And here you can see an overview of the latest runs, the different tasks that are part of it. So yeah, let's dive in. By going to tasks, I can see this DAG, so this directed acyclic graph with the different steps that need to happen. As can be seen here, there's this Twitter stream S3 task. After that, we run a pipeline, then we do some sentiment analysis, and in parallel, we run this languages task. So the goal of this job is to fetch tweets, specific tweets, according to some filter from Twitter. And we want to get these into the lakehouse. So after that is done, we are going to use a Delta Live tables pipeline to clean this data up, filter some things out. And then after that data has been processed and is in our silver layer, we're going to do sentiment analysis on all the tweets and to kind of figure out what is the sentiment around this, while we're also going to do some aggregation to figure out what kind of languages are present in our data set. So what kind of people are tweeting about these things. So let's start with this first task. So we have this Databricks notebook here that lives in our workspace called the Twitter stream S3. Here's some configuration. So you can specify a path. This can be backed by a Git repository, or it can be in the workspace itself. We can specify a cluster that this needs to run on. So in this case, I'm going to use a shared cluster that is also being used by my colleagues, but I can also specify a job cluster that is automated and kind of isolated specifically for this job, which also reduces the amount of money that you have to pay for this. And then there's some bunch of other configuration that we won't go into. And as can be seen here, because everything is very well integrated, I can click here to immediately take a look at the notebook that would be running if we run this job. So I won't go over the whole notebook, but basically we're using this Python library called TweetPy to analyze tweets or fetch tweets from Twitter. We're setting this up. And then here, there's some logic. But what is important here is that we're filtering for hashtag 2023 to kind of get a sentiment of how excited people are for the new year. We've commented out the languages, so any language is okay. And we actually implemented it in a way that we only get 10 tweets in a row. So that can be seen here. What we're actually doing is we're using the Databricks file system, DBFS, which is an abstraction over your cloud storage. In this case, we're running on AWS, but it's exactly the same on Azure or on GCP, where it's basically, referencing the cloud storage. So you can direct this to your cloud storage. Anything that you write to DBFS is written there. Anything that's written to there is accessible through DBFS. And the nice thing is that we have this concept called Fuse that allows you to use it as an actual file system. So Python libraries don't even need to be aware of the fact that you're using cloud storage. You can just use a DBFS path. So anytime this runs, it fetches 10 new tweets. It puts them onto the Databricks file system. And then the next step will put this into tables. So now let's go back to the job. And here you can see the next step. This is a Delta Live Tables pipeline. So Delta Live Tables is our new product that makes ETL very easy. You basically specify exactly how you want your table to look like and what sources this comes from, plus the transformations. And Delta Live Tables makes sure that it is every time that you run this in triggered mode, or you can run this continuously, that any new data is processed exactly once. So take a look here. Here you can see all the different options available for task types. We can now reference this DLT pipeline called tweets DLT. Let's take a look here. And here you can see a graph with the dependencies between the different tables. Before we go into this flow, let's take a look at how this DLT pipeline is defined. Currently, you're using notebooks to define these concepts. So here you can see we're creating or refreshing a streaming live table called bronze. We can set some expectations here. In this case, we don't want to have any sensitive information in there. So if this is violated, so if it is possibly sensitive, this is data provided by Twitter, we will drop these rows from our table. And we're selecting the location where we're ingesting these files from. We're using this product called Autoloader, and Autoloader keeps track of all the files that have been processed already, so that you don't have to worry about moving things around or getting worried about duplicate data. Autoloader will keep track of everything. And then we have a second table that is called Silver. And as you can see here, we're selecting this from another stream, from the live bronze table. And again, here we do some checks. We'll drop rows if they don't adhere to our expectations. And now we've defined basically two live tables. Those can be queried at any time, and they can be updated incrementally. So now if we go back to the DLT pipeline, here we have referenced this path, and here you can see those two tables that were defined. I can now either just run an update, or I can choose to do a full refresh, which means that all the data that was previously processed will do it again, maybe after a massive change to your definition. And then if we want to run this on a schedule, we can reference this pipeline in our Databricks workflow. As can be seen here, this task depends on Twitter Stream S3. That means that Twitter Stream S3 will happen first, and only if it succeeds, that's when we run the pipeline. After the pipeline, we have two other tasks. So we have a sentiment task. This is again using a notebook, but this is using an optimized cluster for machine learning. And what it will do is it will take all the tweets produced by this pipeline and use Hugging Face to do sentiment analysis over that. So let's take a quick look at the notebook here. All the dependencies are pulled in. And then here we're, after doing the predictions, we can see how positive these tweets are according to the language model that we're using. Starting with the most positive one. Well, here people are clearly very excited about 2023. So it seems like our language model is working. And what we can also do is create a word cloud based on these positive ones. And you can see here, happy and new year and welcome, beginning. So this is something that we want to run every time that we update our data. And then this other task is responsible for figuring out what languages are being used when talking about 2023. And we're using Databricks SQL for this. This is our warehouse offering. And as can be seen here, this is a very simple query, but this query is called languages. It's defined. So let's take a look here. And this, now we're going to our DB SQL product. This allows us for very interactive tests, changes, and you can actually see the result here. So actually, Japan apparently tweets a lot about 2023. And here you can see a bar plot. So going back here, we're specifying this query. We're specifying where this query will be executed. Workflows kind of orchestrates the workloads somewhere else on your cluster. In some cases, there is no clusters or endpoints. And yeah, now we've everything is set up, we can start a run. So the run has been triggered. We can see it here by going back to this view. And here you can actually see the history of the latest runs with how long they've taken, if the tasks were all successful. So in this case, everything goes very smoothly. So let's take a look at our previous run from earlier today. And as can be seen here, everything is successful. So everything executed according to plan. Now, if I want to learn more about what happened in here, I can actually click on one of these tasks for the run and get the output here. So here you can see some of the tweets that were written to DBFS. But going back, what is more interesting, for example, is this sentiment analysis. So here we re-executed the sentiment analysis on the news data. We get to this word cloud that we saw before, and we provide some other plots in the notebook about how positive or negative things were. People seem to be relatively optimistic for 2023. So now if we go back to our job run, there's some information available here. So here you can see the compute that was associated. So we were using this shared interactive cluster and a machine learning cluster, and the DB SQL was using this endpoint. So now that we've gone through this use case, I want to highlight a number of other functionalities that were not directly in this use case. So next to the task types that we've seen here, there's a number of other tasks or task types that you can orchestrate through workflows. You can use Python scripts and Python wheels, jars, and Spark Submit to run all kinds of things related to programming. But then there's also the new run job functionality that allows you to trigger a different job so that you can define dependencies between your jobs. There's the DB SQL one that we saw, and there's DBT. So for those of you familiar with DBT, it's a very nice tool or open source tool to allow you to define your data models, and frequently backed by Git. And with this, it allows you to specify the Git repository. We pull in we check out all your models and then run them for you so that you can make that part of your bigger workflow. Other things that are coming soon are if-else conditions, so that certain parts of your job only run under certain circumstances, as well as responding to failures. Related to responding to failures, let's cancel this task. You can also set up notifications. So frequently, our customers are running very important production pipelines through workflows. So understanding that something went wrong can be very important. So you can set up email notifications, or you can use things like webhooks so that you're notified on Slack. And those notifications will provide you with the information required to figure out what's wrong, immediately go to the right place so that it allows you to fix something and run it again. Related to that, we have a function called repair and rerun. In the case that you have a pretty complex DAG and somewhere along the way there was a failure, maybe there was a bug with your code, maybe there was an issue with the data that you were using, you can go ahead and fix that issue and then do a repair on your job run, which means that the run will restart in place at the location where the failure happens. So this allows you to both save time and money by not recomputing all these previous steps that were successful and only start from your failure. Of course, doing these manual runs is nice, but being able to automate things and run them when you need them to run, it's a pretty big part of your orchestrator. So as you can be seen here, now we don't have any trigger setup, but we can provide additional triggers. If you don't have any trigger setup, you can use the API to start new job runs externally. But the Databricks orchestrator can do things for you. So scheduled basically means at predefined moments in time, run like instantiate runs here. So making sure that every night at 2 a.m. You run this so that the next morning the data is ready for consumption by your analysts, or the dashboards are updated for the CEO. But we've also introduced some additional trigger types. One I'm really excited about is called file arrivals. This allows you to specify some location on your cloud storage, so on your S3 paths, your ADLS paths, or on your Google Cloud Storage. And whenever there's new files that come in there, Databricks will notice that, and it will start your job so that this data can be processed as soon as possible. And another mode is a continuous mode. This allows you to basically continuously run specific tasks, and that's really useful for continuous types of jobs. So streaming data from Kafka or continuously monitoring certain things. And lastly, I want to show that of course there can be many jobs with all your colleagues, and getting a proper overview of everything that's going on really helps make sure that things are running smoothly, and being able to see whether there's things that are changing or whether there's multiple failures. Having this overview allows you to basically fix things when things are happening, or just get a better understanding of what's going on. This really helps make sure that the results that your workflows are responsible for are going to be there when you need them, and if they're not, that you can get to those results as soon as possible. Thank you for your time. This is my introduction to workflows, and enjoy the rest of the sessions.
Thank you, Jan, for that great demo. Our next topic is a great real-world example of how Databricks Lakehouse platform is used by Honeywell. We have with us Dr. Chris Inkpen from Honeywell, and he will tell us all about how Honeywell is using some of the capabilities we've heard about, and specifically about Delta Live tables. Here's Chris.
Hi, so my name is Dr. Chris Inkpen. I work for Honeywell. In particular, I work for the HBT, Honeywell Buildings Technology Division. We are an avid user of Databricks, and recently we've also been really excited by what we can achieve using DLT, Delta Live tables. Our main business goals within Honeywell HBT is the ones that are on the screen here. So pharmaceutical, we're primarily interested in giving our customers data governance features. We have healthcare, education, retail, commercial data centers. And as you can see, we have different types of requirements for each one of those key verticals. Retail and data centers are all about alarm management. Energy management is from healthcare and commercial. So we have a huge amount of buildings that we manage on behalf of our customers. the types of main goals of these customers are estate managers, energy managers, and building managers. And the types of things that they're after is really improving the quality of the occupants of their buildings. So estate managers are all about managing sheer quantity of buildings and managing things like alarms across all of their buildings, all of the equipments that have different failures. They want to be able to ship out engineers to go and sort them out. Energy managers are all about optimizing or reducing the cost of running the buildings. Building managers want to make sure that the occupants' health is good, that the spaces are in the right comfortable area. From here, we can basically expand out, and we have huge amounts of potential of providing different services to these types of people. The Honeywell story is really all about people and spaces and data. So if we look at this diagram here, we have the fact that people occupy spaces in buildings, and spaces can also contain other spaces. So you could characterize a space like a building broken down into floors, into areas. And each one of these spaces is monitored by a whole collection of different technology that's providing that sensory information, be it temperatures, humidities, air quality, etc. These are all managed and controlled by pieces of equipment. So these could be things like air handling units or coolers or boilers, depending on which part of the earth you're in. Obviously, you're going to have more heating or more cooling in certain times of the year. So equipment itself can always also be broken down into sub-equipment, like an air handling unit can have fans, it can have filters, it can have heaters and coolers, etc. in it. And all of these are consumers of energy. And where Honeywell comes in is we're monitoring these sensors at a huge scale. We're controlling the equipment in order to improve the spaces for the people. And we're also monitoring the energy so that we can keep an eye on the energy consumption and target particular areas to be reduced. So that's our object model. And that kind of breaks down even more into the types of delta tables that we do and our story of moving from bronze through to gold. So we have hundreds of customers. Each one, particularly in North America, can have thousands of buildings. Those buildings have broken down into floors, into areas, into rooms, and each of those rooms will have hundreds or even thousands of sensors. Some of this data is coming through in like 1 second intervals. Some of it is coming through in intervals of 15, 30 minutes. But we end up with hundreds of thousands of bits of data coming through into our cloud systems, some per second. We could have hundreds of thousands of events per second. So our real magic occurs when we transform all this bronze data into gold outcomes. The silver bits is mostly about our DLT journey, which I'll come to in a bit. But the gold outcomes are things like optimizing the comfort, keeping an eye on the humidity and temperature of our occupants' areas, optimizing the time schedules that the plant's going to come on to heat and cool the areas, and predicting energy. If we can bring in other data sources like the weather and the air pollution, we can actually use that to predict our energy consumption and give warnings to our customers over their likely energy profile in the coming days and weeks. What I'm going to talk about now is really how DLT has helped us provide solutions to all of that. So DLT is really been a massive help in reducing our design complexity. We use a product called Miro, which is actually what you're looking at right now. This is a Miro board. We use Miro to actually design out our complicated transformation strategies as a set of post-it notes, which we then draw lines on to show the transformation. So we actually design all our stuff in Miro. The design complexity using DLT, where you can actually visualize how the transformations are occurring, means we no longer have just loads and loads of code. We've now got a graphical representation of how the design flows. So from receiving our original agile epics to mocking out the design using Miro, we can pretty much prototype the data that we're going to receive and mock it out. So that's another one of the major benefits of DLT, is you can actually plug in and take out and replace it with production data, but you can have mock sources. And we use that to, we've actually implemented an entire unit testing strategy where we throw in mock sources and unit test our entire pipeline automatically using the REST APIs to DLT. So that's some mockable sources. Really the right time at the right tool at the right time. We have in the past developed quite a few traditional jobs, and as I said before, they're not really visual. We can't really see what the transformations are going on. It's not very obvious. It's hard to train and educate the new developers over exactly what it's doing. If we can point them to a DLT pipeline and a visual graph, we can really explain to them and show them the code that's doing the transformation at the same time. That's really, really helped. And it's made the job of sort of running the teams much, much easier now. So DLT has really helped us there. We've had an explosion on the functionality that our customers are demanding. And now we can just mock out the DLT. We can reuse a lot of our existing notebooks that we've got in other DLT pipelines. We can basically use the same code now for very quickly turning around a customer's requirement into a brand new gold table, which our application team then turn into a nice user interface. So as an example of that, we had got some very complicated database manipulation routines written in standard jobs in Python. And we've now, I think that was probably took about 2-3 months to write originally on our first version, but we've now managed to rewrite that in DLT in just a couple of days. We were able to, because we knew exactly what was required, we rewrote that in DLT, and it took less than 2 days. And we can now test out using our testing strategy I mentioned before. We can test out that new pipeline in a matter of minutes and prove that it's still delivering the same functionality that it used to in the past. One of the main things that I love the most about DLT is probably the apply changes. The code complexity we used to go through to do merge operations before DLT was probably the most complicated. It was the most risky. It was the most item that needed the most testing. But the apply changes into is such a simple syntax now that we can do quite complicated merge routines now in minutes rather than in days. So that's basically Honeywell's story. We have a lot of trust in DLT. We think we can now use DLT pretty much for everything transformative we're doing. There's only a couple of things that we have to do outside of DLT, which I believe are probably on DLT's pipeline. Those are writing to external databases and writing to event hubs or Kafka outputs. Within Honeywell, a lot of our business depends upon the ability to deal with both real-time streaming data and historical operations. So our metering data tends to come in 15 or 30-minute time intervals, but those are often delayed by a day or two, whereas our live telemetry data is often hundreds or even thousands of records per second for any one building. So having the ability to have a joint streaming and historical batch operation strategy where we can ingest all of those different sources of data at different rates and join up on historical data is really great. And be able to do all of that inside a single DLT and Databricks platform is really what makes the difference there. So just to quick sum up there. So my name has been Chrisingpen. I work for Honeywell HBT, and we're really excited about what Delta Live Tables and Databricks has been able to offer us. We have a lot of functionality which we are now able to write through different types of streaming technologies, mixing both real-time and historical data in a single platform with so much functionality that going from basic to the pro to the advanced, or core to pro to advanced, we are able to provide the same level of jobs that we used to provide before at the same cost. But we've also had the option now of utilizing some of the advanced features. So we're really, really enabled and buzzed up by what we can now do with DLT. So thanks all for listening, and see you out there.
Thank you, Chris, for sharing that great story on your experience with Databricks and DLT. We'll now hear a little bit more about DLT and workflows in two deep dive sessions from Ray Zhu and Roland Faustlin, both staff product managers at Databricks. We'll start with you, Ray. Take it away.
All right, thanks for having me here. I'm going to spend the next few minutes to give you guys a little bit of an overview and also a deeper dive into Delta Live Table or DLT. DLT is the first ETL framework that uses a simple declarative approach for building and running reliable data pipelines at scale and without any infrastructure management. With DLT, data analysts and data engineers can spend less time on ETL tooling and focus on getting value out of their data. Now, I want to highlight a few of the key DLT capabilities. First, DLT allows you to develop ETL pipelines in a declarative manner, where you define the what as opposed to the how. This approach is much faster and less error-prone during the pipeline development phase. Next, DLT manages your ETL infrastructure, like scaling the compute, recovering from failures, and optimizing table storage performance for you. And third, bad data will occur inevitably from the data source, which eventually impacts your analytics and machine learning workloads downstream. DLT has built-in data quality capability to prevent any bad data from flowing into your production tables and applications. And finally, as more and more data pipelines moving towards streaming for more real-time results, DLT is built with both streaming and batch support from the get-go, and all through a unified API. This is a quick diagram of DLT in the context of the broader lakehouse platform. DLT is the default and best-in-class ETL product sitting on top of the Delta Lake and governed by the Unity Catalog product. The highly performant Photon engine is natively supported and built into DLT for pipeline execution. DLT handles end-to-end ETL from data ingestion to transformation, and again with support for both batch and streaming. Once you get your clean data in the production Delta tables, you can run a variety of downstream workloads like business intelligence, interactive analytics, machine learning, and operational applications, all through the Databricks Lakehouse platform. Now let's take a look at continuous data ingestion, which is typically step 0 of any data workloads. DLT supports continuous data ingestion from a variety of sources like cloud storage systems, message buses, and DBFS. When it comes to cloud storage, which is where the most of the data is stored these days, DLT supports a number of file formats like JSON, CSV, Avro, and Parquet. DLT also supports automatic schema inference, evolution, rescue data column, through a feature called autoloader. In addition to data ingestion, you often need to perform transformations and aggregations on your data before they're ready for downstream consumptions. And an ETL pipeline in the real world could get fairly complicated with lots of dependent steps. These pipelines are hard to develop and even more difficult to maintain when you consider scenarios like failures, reruns, and backfills. DLT lets you define ETL pipelines, whether it's simple or complex, in a declarative manner. What this means is that you tell DLT the intent of how you want your data to look like, and DLT generates the step-by-step ETL pipelines for you. And there are a few advantages of this approach. Number one, it's much less error-prone during a development phase because DLT will check for and generate all dependencies for you. And number two, because DLT generates the ETL pipeline, the engine has inherent knowledge about the data flow, which allows us to deliver valuable features like end-to-end data lineage, automatic failure handling, and backfilling. Change data capture, which has increasingly become a popular workload. Apart from capturing change data from the source, a critical capability for this workload is to insert, update, and delete changes into the target delta table. And before DLT, we provided the merge into feature in the Databricks runtime for the CDC workload, which had a set of limitations and complexities like auto handler. With DLT, we now provide an enhanced version called apply changes into. This new CDC feature allows you to specify a primary key of your change data and the conditions for triggering insert, update, or delete actions. Apply changes into handles out of the order data for you automatically and also supports partial updates for source systems that only produce partial change data. And finally, apply changes into also supports schema evolution as the source data schema changes. Next, data quality, which is among the most important aspects of any data platform and remains a big problem for most data teams. DLT provides a feature called expectation to manage data quality out of the box. You can specify the expectations for your data, such as the value of the data should not be null, as well as what DLT should do when certain data violates this expectation. And some possible violation handling actions include fail the entire pipeline, drop the bad data, alert the users, or in the very near future, you can quarantine the violating data for reprocessing afterwards. And all the data quality related metrics are logged into DLT's event log so that you can query and visualize the observability data for additional insights, which leads me to the next topic, observability with the event log feature. So in addition to the data quality related metrics, DLT also logs other pipeline observability metrics like data lineage, compute scaling events, pipeline execution time, data volume, etc. in a place what we call DLT event log, which itself is also a delta table. And that means you can use Databricks products like DB-SQL or Notebook to query, analyze, visualize, and even set alerts on these observability data stored in the DLT event log. Data platform is increasingly used in mission-critical applications and has an increasing impact on businesses when data is not available, delayed, or being not accurate. We believe that software engineering best practices like environment separation, testing, documentation, and parameterization are equally important for delivering highly available and reliable data platforms. And this is why we built software engineering best practices into DLT by default. DLT supports the separation of development and production environments, as well as testing and documentation capabilities, so that you can have the confidence to deploy any pipeline into your production environment. In addition, DLT also allows you to parameterize your ETL pipelines, which allows you to do things like testing your dev pipeline on a smaller data set and deploy to production on a much larger data set. It also allows you to separate long path and other variables from your pipeline code and apply the same transformation logic to different data sources. ETL pipeline operations, and that's a big deal. Many data teams today spends 20% of their time on pipeline development and 80% on operations and maintenance. For large ETL pipelines, rerun after failure could get fairly complicated when you consider dependencies and duplicates. Next, maintenance like vacuuming and other optimizations need to be performed on your tables in order to achieve good downstream query performance. And lastly, data volume almost always changes. And infrastructure failure like computer networking failure almost always happen over a long enough period of time, which means you also need to carry a pager and spend effort scaling and managing your infrastructure. Now with DLT, we handle all of the above operational work for you so that you don't have to. Our goal is that once you set up your ETL pipelines in DLT, it keeps running reliably forever until you stop it. And finally, I want to cover orchestration with our workflow product. Data pipeline is almost always a part of an end-to-end workflow. For example, once your ETL pipelines are executed successfully, you might want to send out an email notification or maybe update a dashboard in your BI tool, or maybe trigger an update to your machine learning model with the new data. Databricks Workflow is the fully managed orchestration product for the Lakehouse platform. It's multi-cloud and allows you to orchestrate DLT pipelines, as well as any arbitrary tasks to complete an end-to-end workflow. Now I'll hand it over to my colleague to tell you a little bit more about Databricks Workflows. Thank you.
Hey everybody, I'm Roland. I'm a product manager at Databricks, and I'm super excited to talk about workflows today. All right, what is Databricks Workflows? Just a quick recap. Databricks Workflows is reliable orchestration for data analytics and AI, and it allows you to orchestrate anything anywhere. And you can do that in a very simple way. You can author those workflows by clicking and dragging and dropping things together in the UI, enabling anybody in your team to create production-level workflows. It's also deeply integrated into the platform. And so that means your code, your orchestration, your compute, your data, they all live together. All of these things are just one click away from each other, enabling you to work efficiently and getting insights on how your things are getting processed very quickly. It's also proven reliability with 99.95% uptime, just like any other cloud service. And we deliver that in a fully managed fashion. So all of that together are the key value pillars for Databricks Workflows. Now, how can you get, what does that mean for you? How can you get the most value out of that? Well, Databricks Workflows allows you to manage the full lifecycle for your data and AI across any cloud, giving you observability for all of the things that you're doing, allowing you to schedule your workloads based on a time schedule or based on an event trigger if a new file has arrived, or to stream your data through Databricks Workflows. And then you can ingest that data through a variety of tools, through Delta Live Tables, through Autoloader, or through any of our Lakehouse partners like Fivetran. Creating directed acyclic graphs like this one out of dependent tasks. And each of those tasks can be any different type of workload. It could be Spark, it could be non-Spark, it could be a Delta Live Table, DBT, or SQL tasks. And all of this then runs in a fully managed, reliable, and serverless orchestration tool across any of the clouds that you may want to use. So to give you an idea of simple authoring, this is a screenshot of the UI. And this DAG, literally, you can click that together in less than a minute simply by going through the UI. So anybody in your team can now create production-level workflows. It's also deeply integrated into the platform. And we have many different native task types that support things like DB-SQL, Delta Live Tables, and also MLflow and Autoloader, just to give you a few of those examples, making it very easy to create your diverse data workload. Databricks Workflows also offers a jobs API that is, of course, open to any orchestrator. So if you choose to use Azure Data Factory or Airflow, or bring your own script or code or orchestrator, you can, of course, do that. At the same time, we think Workflows is the best orchestrator for the Lakehouse. If you compare it with Azure Data Factory, with Workflows, you get freedom from cloud lock-in. Azure Data Factory really is only on Azure. And you get the full benefits of the full Lakehouse integration. For example, cluster reuse, or ACLs. With Airflow, comparison to Airflow, you get reliability. You don't have to spend time to ensure uptime or maintenance or to do upgrades. We do all of that for you through a fully managed experience. And it's easy to use. You can click together the DAG in the UI with a great UX. It also allows you to consolidate your tools. You don't have to click forth and back between Airflow or where the data is getting processed. And everything is just a click away in a consolidated Databricks tool. So we also offer this whole service as a fully managed experience. So we will show you what's running and what's not running. But that only relates to your data pipelines. We take care of all of the infrastructure that is required to actually schedule and orchestrate these data pipelines. You just need to make sure, and you can now focus on the data pipelines themselves. No longer need to make sure that the infrastructure for the orchestration is running. It's fully managed. We do that at proven reliability of 99.95%, the same as ADF. So let's talk about a few of the use cases for workflows. If you want to orchestrate dependencies of different tasks, you would put those tasks in a workflow and schedule that. If you want to do ingestion or transformation, you would use a Delta Live table, and again, you schedule that in a workflow, or maybe you want to stream that in Delta Live tables directly. And that is actually the best practice for ETL, we think, is to use Delta Live tables. You can also use machine learning, inference, or training by scheduling that through a notebook or multiple notebooks in a workflow. Generally, if you want to execute arbitrary code, call external APIs, or have non-Spark tasks, you can still do that. We orchestrate and we execute arbitrary code in notebooks, jars, Spark, Submit, Python, Wheels, dbt, or dbSQL. You can put all of that in a workflow in the different task types, and we execute that in the sequence that you define. So here's a great example of one of our customers, WoodMac, that are processing 12 billion points of data, and they've saved a lot of money through standardizing on workflows for their automation. And beyond just the cost saving, it also allowed them to collaborate much better. Now that everything is a workflow, those different teams can work much closer together, speak the same language, and collaborate on the same workflows together, saving, again, cost, but also a lot of time and driving innovation. So it's not the end of workflows, though. Workflows is getting even better. So for example, workflows are becoming serverless. With serverless, we not only take care of the orchestration piece for you, but we also take care of optimizing the compute specifically for each of your workloads, giving you high efficiency, running that compute in our account, optimizing run over run, that it gets cheaper or faster. We have a warm pool that allows you to get fast startups below a minute for generic compute and below 10 seconds for dbSQL tasks, for example. It also makes it a lot simpler to set up the compute for your different workloads because we optimize it for you. We take care of all of the infrastructure needs. And if you look at the screenshot on the left, really the only thing that you need to tell us is give that compute definition a name and tell us, do you want that to run as fast as possible, or do you want to optimize cost? And then we take care of the optimization with that goal in mind. We also provide high reliability, and we can be much more reliable than picking an instance type because your cloud provider might be out of that instance type, and then we'll have to ping you and that job's going to fail. But we can actually fail over to another instance type for you. So we can shield you from cloud disruptions much more in a serverless experience. So serverless is already in private preview. Coming to you very soon. We're also enhancing control flows. So you're already able to emit certain values from the tasks like XCOMs, or as we call them, task values. And now, depending on what the value is that you have defined here, you could specify which other task needs to be processed. So that's conditional execution. We can also run tasks to clean up, for example. If one of the tasks failed, then we have to clean up maybe some data or some databases, and that can be run only when it's failed. You'll also be able to trigger other jobs from within a job or from within a DAG. All of these are already in preview, so we're very much looking forward to bringing those to you very soon. And then we have workflows triggers. I'm quite excited about this one because it actually allows you to only run your workloads when there is new data there. So in a very serverless fashion, in our control plane, we pull in a very secure way cloud storage for new file arrival. And then when new data has arrived, we trigger your workload, your workflow. And so that means you don't actually have to spend money or time or processing power when there is no new data there. So that gives you a good balance between latency and cost. And we're actually expanding that capability even more now, allowing you to trigger not only based on file arrival, but also based on table changes. That capability will then also be available in DLT when you schedule it through jobs, or for example, for ingestion. I only want to ingest new data or try to ingest new data if actually new data has arrived. And that's going to be much, much more efficient for you. Monitoring and alerting is, of course, also super important. As you run all of these workloads, you want to know, is everything healthy? Where do I need to look into? And we're providing more visual monitoring now through graphs, giving you a very quick overview of what is running and where do you need to focus on the top issues that you might have had over the last 24 hours. And we'll also provide you alerts if a job is running late or has run late. These alerts you can not only get through emails, but also through webhooks with native integrations into Slack and PagerDuty, or any custom URL of your choice. And we're also adding more information to the email alerts that we already have. So I hope that gave you an overview of how you can make the best use of the capabilities that Workflows already has, which is your orchestrator, the best orchestrator for the Lakehouse, and also the new capabilities that are coming up. Thank you very much.
Thank you both, Ray and Roland. And now we have an opportunity to hear about more real-world use cases from Senior Solution Architect Angela Chu. Angela works on a daily basis with Databricks customers on building data solutions, and she will share some of her learnings about common data engineering challenges and how to solve them. Take it away, Angela.
Thank you, Ori. In my role as a solution architect at Databricks, I've worked with customers across many different industries. What I've found is that it doesn't matter if you're a retailer, a social media company, in the financial sector, or even a government agency. The same challenges of data engineering persist across all of them, and they're the same that I've had myself in my 20 plus years as a data engineer. Across all of this, these are common requirements for data engineering. You need the ability to prove that data is accurate. When the director comes to you asking why there's a spike on that graph, you need to be able to show why it's correct. Data engineers also need the ability to meet the stakeholder SLAs. When the data scientists run a big data extract on your data, it should not shut out all the analysts. You also need to have resilient production pipelines. When the owners of the apps that you source data from released some changes last week, and just let you know today, your pipeline should keep running. You also need the ability to incorporate new requirements. When your analysts are complaining that you haven't added that new field for them yet, oh, and can you back populate it from the beginning of time? You do need to be able to respond to that. You also need easy monitoring and maintenance. When your scheduler software needs to be upgraded before it's out of support, you need to be able to do that while doing the other things on the list. It doesn't matter which industry you're in or the size of your company. These are the requirements for data engineering that I've consistently seen with our customers here at Databricks. In the last segment of our presentation here today, I'm going to show you how some of our customers have implemented the Lakehouse architecture in their environments with Databricks and how they use tools like DLT and workflows to overcome their data engineering challenges and meet their requirements. My first example here is with a healthcare company. A healthcare company has many different types of data. It has health data about its patients in one system, prescription data in another, call center data in a third. It also receives government data and data about clinical trials. Each of these systems is backed by a SQL Server database in this customer's original architecture. SSIS jobs would pull the data out of these databases each day, transform and combine it, and put it in a central data warehouse. As you may have guessed, They were having a lot of issues with this architecture. Some of the pipelines would break in the middle if something in the sources changed, and they would have to be manually recovered on a regular basis. That manual recovery would introduce mistakes, so stakeholders had difficulty trusting the data. The data volume had grown to the point where the daily loads were taking 8 to 10 hours. Loading the central warehouse also slowed down analyst queries, so the jobs could only be run at night. The data engineering team was spending a lot of time on manual maintenance and recovery, so there was a long turnaround time for new features. They needed the data to be faster, accurate, and reliable, and new business requirements were coming in that couldn't be satisfied. This is the new lakehouse architecture that they implemented with Databricks. They started by using Azure Data Factory to write CDC data from their SQL Server databases directly to ADLS Gen 2, cloud storage on Azure. From there, DLT is now used to pick up the data directly from cloud storage, infer the schema, and write it out to bronze delta tables. The autoloader automatically keeps track of what it already picked up and what files are new, so that nothing is skipped or processed more than once. No extra coding is required for this exactly once guarantee. So their code was already simplified. When the schema of the incoming data changes, DLT detects it and automatically restarts to apply the change without human intervention. Downstream table schemas then automatically evolve as they are written to. This resolved the primary cause of the old SSIS pipeline instability. Then they added the logic that was in SSIS to the DLT pipeline to transform the data into cleansed silver tables and gold aggregate tables. At this point, they were able to take advantage of DLT's expectations. They had been having data quality issues. With expectations, they were able to alert on or drop bad rows depending on the criteria. The percentage of rows dropped or alerted on are visible in the pipeline page so that the engineers could see how a pipeline was doing at a glance. Those metrics are automatically captured in a separate delta table for each pipeline. So they were able to create a DB SQL dashboard with the data quality metrics for all of the pipelines that stakeholders could check at any time. This created a dramatic improvement in user confidence in the data. Since the compute for DLT pipeline is separate from the compute used to query the data, they can run their pipelines as often as they want, and analysts and data scientists have much fresher data without their productivity being impacted. While each DLT pipeline can be scheduled independently, some of the DLT pipelines are now scheduled with workflows because inference is being done with an ML model after a DLT pipeline completes. And this was built directly into Databricks, so they didn't need an external scheduler. That was just the beginning for this customer. Their upstream apps are being changed to write events directly to Azure Event Hubs to satisfy lower latency use cases. As a data source transitions, the DLT pipeline associated with it is updated to source from Azure Event Hubs instead, and it is switched from triggered to continuous mode. They didn't have to change any of their business logic to move from batch to streaming because it is unified, and they still get the exactly once guarantee. All of this is happening on managed infrastructure, and there is now a single source of truth that stakeholders have high confidence in. Now let's look at a completely different use case. This is a financial customer, and a financial company has very different data and use cases from a healthcare company. But you'll find that the data engineering challenges are the same. This finance company had both historical and current data for market information, as well as risk data and financial products. They also have a lot of transactions coming through a trading app. The web application writes transactions to Kafka. In their original architecture, they were using custom Python scripts to pull data from the other source systems onto cloud storage, and then using EMR and Airflow orchestration to process all the data and put it in Redshift. The challenges they faced will sound familiar to you. The pipelines were taking hours to complete each day, and again, they could only be run at night so as not to impact the end users. There was also contention for redshift compute during the day, because sometimes data scientists would need to do large data extracts. Reports would get delayed, and analysts wouldn't have the resources they needed to run their queries. The pipelines were very complex, but they weren't publishing the intermediate steps between the raw and fully aggregated data, so it was difficult to tell where data issues were introduced. They were having trouble maintaining their Airflow instance as well. It was an old version that was coming to the end of life, but they couldn't get any downtime to upgrade and test it. On top of all that, for one of the data sources, sometimes data would arrive late. Since there was no way of knowing when exactly new data would land, they would have to start up the pipeline and have most of the compute sit idle while the first task repeatedly checked for the data. Periodically, one of their pipelines also had to do a complete refresh of the data from the beginning when new logic was added. This process is manual, and it put a large amount of strain on Redshift as well. Now this is the lakehouse architecture they implemented with Databricks. Two of the sources were switched to use Kafka Connect to extract CDC data so that most of the data could arrive into the system through the same ingestion method. But one data source was only made available on cloud storage. They replaced their EMR and legacy Python script pipelines with Delta Live tables, and DLT was able to source from both Kafka and cloud storage with the same exactly once guarantee. While performance went from hours to minutes, a big benefit for the stakeholders was that the intermediate steps were also published. They could now see the relationships between the different processing steps at a more granular level, and were able to get quality metrics for each one. Data scientists were also able to directly access the silver tables before the data was aggregated, so they didn't have to create their own logic to process the raw data or creating features for their models. The pipeline that needed complete refreshes when new logic was added is also in DLT. It is no longer manual. After changing the pipeline logic, they just click full refresh in the DLT pipeline UI, and it does the rest. The cluster size doesn't even have to be modified. DLT's enhanced auto-scaling feature detects the large volume and scales to the maximum they specified so that it can process the large load. They are also testing out a new workflows feature that's being previewed today, file triggers. They don't have to start up a pipeline at a specific time and then wait for the data. Instead, Databricks is monitoring the location on storage where the data will land, and the workflow kicks off automatically when the data is present so that no compute is wasted. They have also added their DLT pipelines to workflows with additional tasks afterwards to write to other destinations besides Delta. You can see some of them here on the diagram. As they encounter low latency use cases, they're switching from triggered to continuous mode in their DLT pipelines. And for near real-time to non-Delta syncs, they have started including some structured streaming jobs. All of this is running on managed infrastructure. They no longer need to upgrade their Airflow instance because they've gotten rid of it. Because of the variety of task types that can be run in Databricks workflows, notebooks, Python scripts and wheels, DLT pipelines, jar files, SQL, and even Spark Submit, they were able to consolidate everything and get rid of scheduler maintenance completely. As you can see, even with two completely different use cases, the data engineering challenges are the same, and the solutions have also been the same. You can get reliable pipelines with DLT, give confidence to your users with the visibility that DLT and workflows provides. Your maintenance is greatly reduced so that data engineers have more time to provide new features and focus on logic and not maintenance or infrastructure. Thank you very much for letting me share this with you. And back to you, Ori.
We're now moving to the panel for some questions and answers from all of you. And we've seen some great questions coming in already. So thank you all for joining. So feel free to drop some additional questions right now in the Q&A box. I will start with the few that I really wanted to go back to that we've seen throughout the webinar today. I'll start with you, Michael. When you spoke briefly about Delta, and there was a question that came in about Delta Lake. Can it be hosted on premises or in a private cloud?
Absolutely. Delta is 100% open source. You can run it anywhere you can run Java code or Rust code. So yeah, you can use it locally. You can use it, on your own. So yeah, totally.
Great, awesome. Another one that we saw regarding, maybe also kind of connected to Delta, is a little bit about the difference between Delta tables and Delta live tables. I think we also heard a couple of questions about streaming tables. Can you help us kind of sort out a little bit of these concepts?
Yeah, definitely. So let's start with Delta tables, because that's kind of the foundation layer at the bottom. Delta tables are just a layer on top of Parquet. So Parquet is this columnar way to store data. And what Delta brings to your Parquet files is ACID transactions. So rather than just being a random collection of files stored out on S3 or ADLS or HDFS if you're running locally, Delta makes it a proper relational table. You can update it, you can delete it, you can merge it. If concurrent people do it at the same time, it guarantees that you'll still get the correct results. It enforces schema and other constraints. And so it starts looking a lot more like a data warehouse while maintaining those great properties of a data lake, in that it's infinitely scalable and super cheap to operate. Structured streaming is a kind of a general way in Apache Spark to process data incrementally. So it can read from a wide variety of different data sources, Kafka, Kinesis, files written out to S3, or also Delta tables. One of the coolest features about Delta is it is both a streaming source and a streaming sink. So a pretty common pattern that you'll see is people read from something like Kafka, write to Delta, then read from Delta, do more transformations, write to Delta. And that kind of brings us to Delta Live Tables. Delta Live Tables is a declarative framework that sits on top of this. So it uses Delta, it uses structured streaming, it uses Apache Spark. And what it allows you to do is declaratively define all of the different tables that should exist inside of your data lake. And then it automatically manages the creation and the maintenance of these tables. So as new data arrives, it will trickle it through your pipeline. It'll enforce quality. It will automatically manage the cluster, making sure that it's the right size. It will automatically handle all of those kind of messy cloud problems like machines disappearing or ooming. It has the smart retries and other stuff like that. So that's kind of how all of these different pieces fit together.
Great, thank you. Maybe on to you, Roland. I saw a couple of questions about kind of trying to use workflows for error handling. Can you maybe speak a little bit more about the monitoring you can do with workflows, and actually also DLT?
Yeah, absolutely. So we have a bunch of great monitoring and observability features for you in Databricks workflows and in Databricks overall. And obviously also in DLT. And I think one of the great advantages already starts with that. If you look at your workflow and you see something has failed, or if you just want to check like how long did it actually take to execute and what were the things that took the longest, everything that is related to your workflow is just one click away. You could look at the code within one click. It's in the same platform. You can update your code and then quickly rerun. You don't even have to change the tools. It's fully integrated. Then, of course, we do give you all that monitoring. You can check for every run, how long did it take, which were the tasks, which task has failed. You can repair and rerun if something goes wrong. And we will, of course, alert you if something goes wrong. We will not only alert you when something goes wrong, but we'll also alert you when your jobs take longer than usual. You can set limits on that, and then we'll also set you an alert. So for those runaways. And then, of course, same thing applies to DLT. You can schedule DLT just like any other task type. And we have a very diverse set of task types that are supported with workflows. And then you'll also get that monitoring there when they run over. And obviously, the pipeline itself is then also just one click away because you are in the same platform. We're also working on a private preview for something we call system tables, which will allow you to actually define your own monitoring solution to some degree. That allows you basically to query how did those runs go over the last month, over the last 6 months, half a year, and how much did they cost? For cost observability, how much did they cost by tag, by team, for certain types of pipelines, what compute did they use. So gives you much more flexibility and customizability in how you monitor, both cost as well as for long-term performance improvement. That gives you an idea of the capability we have.
Yeah, great, Roland. Thank you. And as you covered, there's so much good stuff coming in, right? The roadmap is really rich with more and more things every day. So everybody just keep an eye on that. Angela, maybe you can take the next one. This is a question I really like coming in. Somebody asked, like, how do workflows and DLT really help in the day-to-day life of a data engineer? Like, what are the big benefits that you see, especially when you're kind of working with data engineers out in the wild, right?
Oh, absolutely. One of the big ones is just pushing something to production. I mean, there's always, when you're getting from development over to production, there is always this big, this big lag. Okay, now that I've developed it, I need to productionalize it. How do I figure out how to get the airflow DAG up? How do I figure out, who's going to monitor this thing? And with tools like DLT and workflows, we're practically carrying the pager for you. DLT itself is going to have retries under the hood so that when you're in production, if there's a schema change, that's something that's pretty typical, it's going to restart for you to capture that schema change and keep moving. Even if DLT is upgraded, when it's upgraded and for some reason there's a compatibility issue, it will roll itself back to the previous version where your workflow was working, and then it will email us and tag your pipeline with that and let us know, and we'll work with you. And then over in workflows, it gives you that visibility so that you can see which tasks are related to which. You can get notified when something executes, when something fails. You can get, so just that productionalization is one of the big benefits of data engineering with workflows and DLT that I see getting used. And then another one is just making it simple. For DLT, you suddenly get this simplified syntax, and it's been huge, especially for folks coming from a SQL background. They've been dependent on data engineers to do these pipelines so that then they can go and do a little bit in SQL. Now they can easily write those pipelines directly in SQL. So suddenly you can have a data engineer or a data analyst. They can still create a pipeline that will get their work done. So it ends up merging these capabilities and making it simpler across the board. So those are two of the biggest that I've seen in general.
Yeah, great. And I think we also heard from Chris from Honeywell how just moving to Delta live tables just enabled them to define these ETL pipelines in minutes and hours instead of days and days, and how that really helps them innovate faster and just move faster. So really simplifying things and just making it all just be faster. So that's great. Frank, on to you. This one's about streaming. I've seen a couple of questions here coming in about Spark structured streaming versus DLT, and also how does Kafka fit into all these pipelines? Can you help us sort out kind of what to think about when kind of creating an architecture for streaming?
Yeah, sure. Happy to help here. So if you create a streaming data pipeline, the default way to do this, from our opinion, is DLT, because it's the easiest. All you need to do is write a little bit of SQL code. It's declarative code. You tell the system what you expect, and we do all the rest for you, including all the infrastructure management, which is typically the hardest part for a data engineer. I think Michael did a great explanation about Spark structured streaming. That would be like much more low level, which you typically don't need. The question for Kafka, Kafka is a messaging broker. It's data that we ingest. We can do this with DLT, with Delta Live Tables as well. And so it's not one versus the other. It's a classical scenario that people have data coming up, like IoT data showing up in a Kafka topic. And then the easiest way to create a streaming data pipeline is using DLT, directly connect to the Kafka topic, ingest the data, transform the data, and then store the data permanently in a gold table, in a Delta table. Yeah, that's about it.
Great, thank you. Back to you, Michael. I see a question about the volume of data that DLT can handle. Maybe you can speak to that a little bit about the scalability.
Yeah, so the magic trick of DLT is it's using Spark and structured streaming under the covers. So it can scale as big as those systems can. And I can say we have done some very large multi-petabyte ingestions using structured streaming. In fact, I think we have at one point ingested so fast that we started to overload S3, which is, I think, very surprising.
That speaks to something, yep. Yeah, and I think speaking to the scale in general of Delta Lake, we see Databricks customers such as Akamai using it to look after something like 30% of the entire traffic of the internet goes through Akamai. So Delta Lake can scale to that. You can probably scale to your workload as well, I think. One more, maybe last one for you, Roland, because we are approaching that. We're seeing so many questions. I just can't go fast enough. But another one for workflows, I think something that came up during the demo. Do you need a good understanding of Python to do workflows or a specific language, or how flexible it is? I think it was kind of said, but please, if you can kind of elaborate a little bit more about the different kind of tasks you can use in a workflow.
Yeah, so Workflows supports a diverse set of different task types, as we call them. And so that means you can use notebooks, and notebooks has, for example, SQL and Python that you can use in a notebook. But then you can also use DB-SQL, which is another new and actually pretty popular task type to use with workflows. So that is obviously SQL. And then you can also provide jars, wheels, those types of tasks we also support. And then we also support, for example, I mean, obviously DLT, but also DBT. If you think about that, that gives you really a lot of flexibility in terms of what kind of code you want to write and what we actually orchestrate. Ultimately, we run arbitrary code. So that also means every of those task types can also do calls to any other system that you might need to orchestrate. So that really means we can run anything anywhere. Hopefully that helps. Very diverse set of task types we have.
Maybe one thing to add there, Roland, is that to actually define your workflows, you don't need to code anything at all. You can use the user interface to link the different tasks together. So if you're a SQL analyst and you have a few queries, you can just click those together and schedule them to run at the right moment.
Absolutely. Yeah, thanks, Jan. Yeah, that makes it really easy and enables a much larger set of your team to actually create those production level workflows on their own without supervision and help from specialized teams.
Great. Thank you both, Jan and Roland. Unfortunately, we're kind of out of time now for this panel, but a lot of great questions. I just want to maybe reiterate one more thing. I see a lot of questions on the voucher. You have links to both under the Learn More. So I still see questions on how to do that. You'll get those. You'll also get an email if you've attended that has those links as well. So, and all of this is recorded and will be sent back to you. So I really want to finish up by thanking all our great speakers, thanking this panel for answering the questions, and thanking all of you attendees. If you're watching this live or if you're watching this on demand, thank you so much for joining us today. And we're really excited to see what you continue and build with the Lakehouse, and hope to see you in future Databricks events. Thank you.